Today we're talking about my favorite part of aerodynamics, the airfoil. The reason it's my favorite part is because that's what causes us to go up. And aviation would be a pretty stupid industry if we couldn't go up. So this is your basic shape of an airfoil. Let's go ahead and define it real quick first before we start talking about how everything works. Point right here at the very leading edge is called the leading edge. So this is the leading edge of the airfoil. This one right back here, right at the very tip, is the trailing edge. Back tip is called the trailing edge of the airfoil. So far that's pretty easy. If we draw a line like I have right here from the trailing edge to the leading edge, this is our chord line. So the chord line goes from the trailing edge to the leading edge all the way through the airframe. Now, if we draw a line that goes from the midway point between the lower and the upper surfaces of the airfoil, it's going to look a little bit like this. And a cambered airfoil is going to be kind of bowed. That line right there, that is our camber. That's the camber of the airfoil. And then if we take the relative wind, say the wind is blowing straight in from this direction, we can get rid of our leading edge here. We already wrote that down on the paper. The wind blows in straight in from this direction. The degree between the chord line and the relative wind is our angle of attack. So angle of attack is the difference between the chord line and the direction of the relative wind. Now, the relative wind can be coming down like this, and then you have a really big angle of attack. The relative wind can also be coming from the top, and then you have an angle of attack in this direction. So those are our definitions. Now let's kind of talk about how this works. Before we can get into how the airfoil works, we have to talk about Bernoulli's principle. What Bernoulli's principle says is if we have an object, now we have a ball, and a fluid runs over it, say we turn on a faucet. There's my beautiful faucet, and it flows water right down at this edge. What Bernoulli's principle says is going to happen is this water is going to exit in this direction because it pulls off the edge of our object and sticks to it. So in this case, our water would be flowing and getting pulled off in this direction. Now that's very important when it comes to an airframe or an airfoil because that's exactly what happens with our air. Our wind comes in from over here, it rises up and sticks, just like on that ball, to the top of our airfoil, and that causes the wind to leave at a downward angle. That's how we get our equal and opposite reaction, which is Newton's law, that everything has to have an equal and opposite reaction. We push the air down, and that's what pushes the airfoil up. So if we add a few more of these lines of what the air does, encountering an airfoil. On the bottom, it just kind of stays pretty flat until it gets to here. So now what we're seeing is the air actually dips a little bit right in front, and then it starts to squeeze in over the top as more and more air rushes over it. It makes a low pressure area on the top of the airfoil. And so if we look at the airfoil not by air flowing over it, but by the pressure zones that it's making, the airfoil starts making pressure zones. These are low pressure zones pulling up to about right here, and then they start to decrease along the top of the airframe until they get to the trailing edge and they stop. There's a little bit of low pressure created right here, but only a little bit. But the bottom side starts creating high pressure, pushing up. Again, this works hand in hand with the air running over, creating this low pressure area, leaving in a downward angle, and high pressure pushing up on the airframes, low pressure, all gives us the rising lifting motion that we all like. There are some other more complicated things that go on with the airfoil itself, such as air rushes around the airfoil around the airfoil as we start to create lift, and that circulation that helps in the whole effect. And then the angle of attack, which again is our difference between relative wind and our chord line. Angle of attack depends how much lift we're able to get out of this airfoil. So if we take the whole airfoil and we tilt it up to a high angle of attack like this, you'll be able to get more lift to a point. That point where you stop creating lift is called a stall. And so what happens during a stall is the wind comes in, it hits the top, it creates that high pressure, and then it comes to a point, wherever the stalling point is, where the air actually breaks away and goes turbulent back here and no longer causes lift. And that determines how much lift that airfoil is able to make, how much angle of attack it's able to put in before it causes that stall. Nobody loves a stall, then our airfoil isn't causing us to go up anymore. So that's the basics of an airfoil. Again, let's just run through the definitions and recap. Leading edge, trailing edge to the leading edge, the chord line, the line that goes in between the top surface and